Hi, everyone. Thanks for being here today. I'm going to be talking about operational technology and cybersecurity concerns for its usage in public infrastructure. So by public infrastructure, I'm talking universities, hospitals, government entities, those types of organizations who may not traditionally think of themselves as having operational technology, but who face these challenges. A little difficulty with the pointer. A little bit about me. I'm OT Cybersecurity Team Lead with Applied Control Engineering. We're a control systems engineering and integration firm, so that includes OT and other things related to that. Been in various industries and verticals, used to work in commercial nuclear power, used to work in building automation for a while before coming to Applied Control Engineering. So I've seen kind of the gamut of sophisticated to unsophisticated organizations and what is and isn't present for cybersecurity. So the things in detail that I want to cover, common operational technologies, what these things are, which you may or may not know about in your institutions, get a baseline on those devices and what cybersecurity means for those types of devices, and how it is that you end up with them on your networks and in your realm of responsibility, and then how you can make sure those things that end up on your network are secured in the fashion that you want them to be. Starting with OT, OT is about controlling physical processes. So the machines are in control of a process, motor, pump, valve. So there's directly interfacing with the physical world, and then there's interfacing with humans. So you may be so lucky as to have an HMI that has these spiffy 90s graphics. An HMI is a human-machine interface. That's what an operator is going to use to interface with a piece of equipment to do their job. So these are computers, right? And they have the same problems that all other computers have, but they're not talked about like computers. They're talked about like the piece of equipment they're associated with, which means there's a lot more obscurity problems and a different mentality when it comes to them. And what does that mean as far as differences between traditional IT, right? So kind of the common refrain is that IT focuses on data security and OT focuses on functionality. Data is often a lot less important in OT, right? If someone steals the temperature of this building right now, probably not a big problem, not compared to someone stealing, all of our emails. If someone stops the HVAC system from working in this building and the pipes freeze over the night, big problem. So despite the fact that there are these differences, the cybersecurity threats to these devices are the same as any other computer, right? And these technologies are becoming more and more similar. The de facto standard is regular TCP/IP-based Ethernet networking for communication protocols for these domain-specific devices. And what are these devices doing in public infrastructure? They are the critical infrastructure of public infrastructure, right? So they're providing the critical utilities for a hospital or university to function. So chilled water, heating, electricity, right? So every hospital has some form of standby generation, right? And this can be a really complex cogeneration steam plant with multiple turbine generators and burner units and a very complex control system. It can be real simple, some modular boilers installed by an HVAC contractor. But they're there and they're important, right, for that organization to function. A couple more examples. So you may see these around your building, out back near the loading docks, cooling towers, chillers, steam plant. And what I like about this one, hopefully my laser pointer works, if you look right here, amongst all these control panels and big switches, we got a computer monitor hanging off on an arm off of this panel here. So what we have is a chiller, but also what we have is we got a Windows computer hidden inside this box and this screen that I wouldn't be surprised if anyone can walk up to it and do whatever they want with it, right? So how'd you end up with that computer? Someone didn't go, to the IT department and say, hey, procure me a desktop. there was a project to purchase a chiller, and a chiller was purchased. That's the unit. That's the system that was purchased. So the system doesn't present as a cyber asset. It's the components of that system that are in question here, right? So here's a picture of a drawing that we made for a system, right? And I know what I'm looking at. I know that I'm looking at an Ethernet switch, a managed Ethernet switch, made by Cisco, in fact, but branded differently. I'm looking at a processing computer that controls an air handling unit and that has firmware that needs to be updated. I'm looking at least 2 Ethernet NICs that have nearly as good as a KEV that was released this summer. The NSA found code in the wild capable of attacking these devices, right? So they need firmware updated. But they're inside one of those sheet metal boxes down there in the boiler room. So device types, network switches, industrial small form factor PCs, server computers in the control room, providing centralized control and monitoring. And then, of course, the specialized firmware-style devices. So when we start to talk about cybersecurity for those devices, we open a big can of worms here. And if we look on the right-hand side, what we have, where's my laser there? This is a representation of the Purdue model, which is kind of the fundamental information computing model for control systems. So it's broken up into levels, not to be confused with OSI, ISO layers. So level 1 is where you have your devices that are actually executing the control routines that are programmed to control the piece of equipment. They know when things need to be on and off, and they attempt to do that in as automated a fashion as possible. That's your level 1 type devices. Level 2 is when you start to get into more your traditional IT type devices. Here's where you have not only kind of firmware, simple style user interface devices. This is where you just get into regular old Windows computers, Windows 10 desktops, Windows XP desktops still, right? Because did you go and replace the entire piece of equipment just to get rid of that computer? It's a lot more expensive. Servers, etc. And then level 3 is when you get into really more traditional server infrastructure-based systems, centralized monitoring, etc. So today, level 1 and level 2 are going to be kind of the biggest topics at hand, but really all these levels are relevant. And if we look at the mess on the left, which is a diagram from Cisco, I'm sure a lot of us recognize what this is. It's a logical network diagram. Little blend, logical and physical, right? But pieces of it look different, right? So I've got rings all the way down here at the edge device. And if I look, where am I looking for? If I look over here, I've got daisy chains. I have different types of technologies in use here down at the lowest layers. And there are reasons for that, right? There are reasons of reliability, why I might want to interconnect the control devices together and not run them through a network switch. Maybe I don't want to make the statement, hey, this IDF has to be up in order for the pipes not to freeze. Maybe I just want to rely on the controllers, which have better defined MTBFs. So there are functional reasons for the way that many of these things are, but these pose additional challenges when it comes to trying to make a secure environment, right? Because if I don't have all these devices communicating through a switch, how do I do network monitoring? Those are the kind of questions that you have to balance. And despite all the talk of convergence, OT is at a different stage of maturity when it comes to the device and software level model. So the IT world is really trying to move past the network as a security barrier, right? That's what zero trust is. Zero trust is I'm not going to ascribe any security relevance to the network layer. I'm going to have at the application layer, every action is going to be authenticated and authorized and matching the permission scheme. HTTPS, needs to stay in the mix too, but primarily we're handling security at the application layer, right? And that is not true in OT. And I can't make it true right now because these protocols that are industry standard that devices from different manufacturers utilize and that I have to utilize to integrate the system, they're open, right? So if I'm on the network, if I'm on the network with the device, I can tell it to do whatever I want. That's not a vulnerability. That's the way the protocol works, right? It's the same as ARP. It's not a vulnerability that I can send an ARP command. That's just part of ARP. And that's the same thing with these protocols. So the network has a lot more importance when it comes to OT security still. Relying on segmentation at the PHY and MAC layers, relying on VPN, transport layer. And the network really is the most important security layer. And the network is also responsible for allowing the critical functions of the system to still be performed. So systems are engineered right now in a distributed fashion, which is good in many ways for reliability, right? But it means that there are cases where devices have to talk to each other in order to perform the critical function. And when I talk about the critical function, I'm talking about operating the piece of equipment. I'm talking about spinning that turbine, generating electricity for the site, what have you. And that is the thing that needs to be protected more so than the data on any of those endpoint devices, which again increases the importance of the network layer. So you have to develop design criteria in order to start to add cybersecurity into this environment. And you have to contend with challenges of a linear daisy chain topology still being something that people are perfectly okay using. So, talked about the devices, talked about how they're hiding there in the boiler room, steam plant of your site. How did they end up there without anyone asking you? And why is someone asking to connect it to the network? And why are they asking for it right now? So the devices probably got there by a job that was bid based on engineered specs that were produced for your facility. So an engineering group or an architect produced engineering specifications which define how things in the facility are supposed to work, what they're supposed to do, how that's supposed to be done. And these are kind of the technical basis for all construction that needs to happen at the site. And then a bid package is going to be put together with those specs, which is kind of the standard baseline. Then we're going to have drawings and a scope of work that show what the specific project is that's going to utilize those specifications. And then in the case of a government entity, right, that's going to go out to public bid. So here's where you can go check out what things Delaware has out for bid. You can go there right now and find jobs that are, things like chiller replacements, boiler upgrades for public buildings in the state. You can find the specs, you can find the bid packages, and that's true for a lot of public organizations. So we have the scope of work and the drawing package and the specification, and they are prepared for the project, which again is something like, okay, we need to upgrade our chillers to have more capacity to add a new building at the site. We need to have a powerhouse so that we're no longer having power outages from the utility. So that's the project, and that has a lot of things besides operational technology, besides technology, period, right? That has, someone's got to pour a concrete foundation for that new powerhouse building. It's got a lot of other disciplines and trades involved in it. And the engineering package needs to speak to all of those. So that's the level of detail that is having to address. And the technology components, as you can imagine, is a small sliver of that. So the specifications for the work that's going to be done need to answer the questions of, what are the technical qualities, parameters of the stuff that you're going to give me, that the contractor is going to provide, and what are they going to do with it to give you the functioning system in the end. So the materials and then how they execute with the materials. That's what the specifications seek to control to make sure you get your desired end product. In the US, those are going to look like a CSI master format style specification. So this is a standard that's put out by Construction Standards Institute. The 50 divisions, so we're talking about how this needs to encompass all engineering disciplines, all parts of the project, right? So that's how we end up with 50 divisions. They're organized in line with trades, different engineering disciplines, right? So you've got things like your typical construction, masonry, carpentry, And then eventually you get to things that have computers in them, like Division 23, heating, ventilation, and air conditioning. So that's where the controllers that are going to be on possibly your boiler, possibly the HVAC unit in the server room that's making sure the servers don't overheat. Division 23 could be in Division 25 if it's a big enough job. Could be in Division 40 if it's leaning more towards an industrial style job. So these are the most common divisions. It can show up in other places. It's not going to show up in all 50. Fortunately, there is no OT in the masonry division yet. But the electrical power metering system, that gets into digital devices. So it does show up in some other places. And the master format, this is not the only way that specs are made. You can feel free to do whatever you want. It's just the most common, and if you see a different one, it's the same concept with the way it's organized into different units based on divisions, the type of work, the type of discipline. So let's break open some of these divisions, and there can be subsections and sections if I want to describe, how something is supposed to happen at different parts of the site, but it's the same type of system like HVAC. When I finally get to my section or subsection, I'm going to see three things. I'm going to see my part one, I'm going to see general. This is where I've got quality requirements, warranty. I might have something sort of like a system description. I'm going to have things like required, bid list, references, standards that the system's supposed to meet. These type of things will be higher level and in general. I'm going to have two, which is product. So this is the stuff I'm going to get. And if the stuff that I'm talking about is an Ethernet switch, the parameters of what Ethernet switch I'm allowed to supply is going to be in part two. And then part three is execution, which is, okay, when I get that Ethernet switch, here's what I'm going to do with it. So I'm talking about Ethernet switch, but again, we got to remember that we're operating more at the system level. So this is an example. This is an example of a table of contents from a spec that I pulled from the internet, from a university. You can feel free to look these up. They're very easy to get. You can just Google University Building Automation Specification, University Division, such and such spec, freely available. They start to look very similar, and you'll see that we've got things which are more recognizable, as they could be computers, like a workstation. We got things that are less recognizable, like analog sensors, thermostats, valves. So these things are part of the system and approach from the system level, and you have to suss out the pieces that are relevant if you are looking for operational technology impacts. So this spec is going to define what you receive. So the components that are going to be supplied are going to match the Part 2 requirements in that division. And the way they're going to be deployed is going to match what's in Part 3. And the person doing that may be even farther removed from you, the security responsible holder of the facility, than even at 1 or 2 degrees, right? Because remember, we're talking about an entire chiller replacement. The controls contractor is not going to bid chiller replacement. That's going to be bid by a prime contractor, which is typically general construction, mechanical, depends on the situation. But unless it's a very small specific job, the entire job is going to be bid by a prime, and whoever is doing the operational technology component is going to be sub to them, and what they're providing is something that the prime agreed to, and they rolled up into their contract. And this puts security at a severe disadvantage if it's not at the spec, because if you have to do extra things to that system beyond what's in the spec, that's likely going to take more time, that's going to increase your cost, and you're going to lose the bid. A lot of governmental organizations, by law, have to pick the lowest bidder, right? So it doesn't matter how considerate I'm trying to be. If I want to add time to go through and change all the default passwords on these 20 devices that I'm having to throw into the system, that's going to disadvantage someone, and it's going to go to the person who's not going to do that. And it's not just the time it takes to change that password, right? So if I'm not doing anything, then I'm not creating more work for myself. If I decide I need to change those default passwords on all 20 HVAC controllers, that means I got to change them. Okay, maybe not that long. It means now I got to manage a KeyPass database for a customer. So I got to do that, and then that's fine enough for me. But then I got to teach everyone else in the office how to use that. I got to teach the technicians how to do that. I got to make sure they have it on their laptop. I got to make sure they can access the database at 2 a.m. when they're on a service call and they need to get in the system to help troubleshoot why something's not turning on or why it's providing the wrong indication. Again, things that are not in the spec are at a disadvantage for showing up at site. So let's look at some more examples, of things that are in specifications. Most of these are Division 25, I believe, which is building automation. Here's a Part 1 example. We can see some of those high-level constraints, right? So I've already limited the technologies that can be used in the system. So this is not a technology evaluation anymore. And there's good reason for that, right? Do you really want to double project cost for adding 3 new offices, for someone to recreate all the graphics and integration for, some no-name cheap controller someone tried to throw in? And then if we look up here, right, who's responsible for maintaining this stuff? Facilities operations controls department is responsible for maintaining these systems, right? And that's probably the computers and the embedded style controllers. So these things have to be set up for them to use it. They're the end user. And you kind of want to stick to the environment that exists for that to be an efficient process. Here's an example of Part 2 from a different spec, and here's where we're moving back right into stuff we recognize. Here's a PC, an operator workstation. So provide each PC-based operator workstation. Okay, so here's how you end up with that Windows XP PC in your boiler plant downstairs in that sheet metal box. Because the spec asked. That's what you guys wanted to buy. That's what the facilities engineering project indicated needed to be bought for the system. Connect to LAN as required. If it doesn't exist, then the contractor shall develop their own architecture. So here's how you end up with some network that you didn't design, and now someone's trying to tie it into your system. Doesn't say anything here about IP addresses, subnet selection. It says I got to have 20% reserve capacity, and I got to have store and forward switches. So I'll make sure that I pick up store and forward switches instead of Ethernet hubs from the Best Buy. But this is getting into the devices that impact security posture. Here's a different Part 2 from another building automation spec. And here we're asking for something different, and you're going to get something different. So if I look, we'll coordinate with IT to provide all network connections. No dedicated network switching or routed equipment is permitted to be installed by the contractor. So now you're in control of the network that you want to have. So you have to make sure you provide it, or else people will be upset if they show up to do the install and it's not ready. But you get to control that aspect of the security posture. What else do we have here? Okay, well, we got to have the latest Windows release. That's helping. We're defining the computing architecture that needs to be used, and we're limiting their scope to the software. So that's going to let you have the baseline on those systems that you want. Let's get into Part 3, which is what someone is going to do with that equipment they put together from Part 2. And again, right, this is for the building automation system. So I've got buried in here with my things talk about my air handler and my VAV, which are the boxes above the drop ceiling here that are deciding how much air goes into the room. Now I got some notes about my computer network. And here again, we're kind of getting into a less well specified situation where you're going to have something that's fighting your security posture. So we're just saying I got to have at least one workstation per building. I got to say it's going to be able to talk to the database on the file server. So it doesn't say that I need to set the file server up not to use SMB1 or I can't use FTP. Better would be if it said, here's what you have to use, at least SFTP or HTTPS or SMB3, whatever you want. These are the type of issues that Part 3 introduces. And talking about all of these were just specs that are part of the facility work. Here's one that's actually was out for bid when I went and Googled it. And it was the first one that came up for chiller replacement. That's the only reason I picked it. So I'm not picking on them specifically or the engineering firm or anything. But the state of Delaware Police Headquarters, okay, that's not something where someone's expecting there to be operational technology. But here we are. We have a building automation system that shall be interfaced into the facilities management network, extension of the existing, and the contractor needs to wholly supply new systems. So this is something that off the bat is not doing a lot to control the security posture of these devices. And in fact, the only place that cyber or security shows up in the specification is down on like a rider in an appendix, which is the owner can feel free to purchase cybersecurity insurance for them if they want. So this is not the contractor has to purchase cybersecurity insurance. This is for the end user. So what do we want to have in the spec, right? We don't want to have uncontrolled devices. We don't want to have things that are going to introduce more problems into your vulnerability scan. We don't want things that are making your security posture worse, right? These are devices that are adding attack surfaces to your system, to your institution. That's the problem, right? And we want to solve that. So we want to put security in the spec. We want to say that this is one of those technical parameters that needs to be covered by the system that's provided. It needs to be in the spec. It needs to be effective. So you want to speak to both of those parts of what is it that you're receiving and how should it be set up, how should it be executed. And these aren't things that you have to come up with from scratch, right? So besides individual institutions, example specs or what have you, the unified facility criteria and unified facility guide specifications. So this is a set of engineering specifications. So there's the specs, and then there's a whole other set of documents speaking to the rationale and design principles of the specifications. The specs themselves are boilerplate style, where they got a lot of sections, and you kind of pick and choose what you want. So that and the whole building design guide is run by the U.S. Army Corps of Engineers, and it is an attempt to take all of the institutional knowledge from all of the branches of the military, from NASA, from other governmental organizations, and say, here is a clean, strong basis for the specifications that these facilities should be using. And we'll dive into that a little bit more. So the specs that you're choosing, they need to reflect your cybersecurity program. And I'm sure that this was marketed as a supply chain issue, right? So now we get into supply chain. What's one of the biggest supply chain controls in most cybersecurity programs? Well, it's vetting of vendors who are going to access the network. That's something that's appropriate to include before the bidding process instead of scrambling after the bid has been awarded with, okay, you guys got to fill out this form and risk is going to look at it. There's not really much to do with it besides look at it because you've already been granted the bid. Instead, that's something that you could talk to your facilities group and say, hey, we need to cover these things before someone is doing work, before they're changing the system. How can we work with you? How can we work with whoever is the consulting engineer to have these requirements, which are already the institution's requirements, spoken to in the place they need to be in the engineering specification. Make sure they're realistic. If what you're looking for is a HVAC contractor who has SOC 2, you're probably not going to find it. And for good reason, right? So SOC 2 is about protecting your data, that someone's not going to lose your stuff. And that's the critical parameter when it comes to an information system. That's not the critical parameter you're really trying to protect when it comes to this system. You're trying to protect the posture. Lean on existing sources. This is how you can get the specification to get you the system that you want. So, I talked about example specifications. There are standards specifically for OT cybersecurity. ISA 62443 is one of the biggest families. The NIST 800 series, I'm sure some of you are familiar with. 882 is the tailoring for ICS, industrial control systems. That's what OT falls into. They just released Rev 3 maybe in September, and they retailored it. Obviously, it was written against solely RMF before. Now it's been reorganized around CSF, which is quite helpful. So lean on that. Pull out the things in these standards and in these examples that you want whoever is doing the work to deliver to you. They are touching the device. Here's the things you want them to do while they're touching the device. And also make sure you pull out those things that you want to be responsible for, right? If you want to be in charge of the network design, then make it so that you are in charge of the network design and you're controlling the way that they interact with it, which is whether that's only requesting IP addresses, whether that's having to have the design vetted beforehand. Pick those pieces of the OT computing infrastructure that make the most sense for you who knows your environment to be in control of. Domain controllers, DNS, network, central services. It's better for everyone, remote access. It's better for everyone that you're in control of some of these things, right? And having them be consistent and monitored instead of requiring each individual vendor to come up with their own remote access solution, which is going to be some cellular gateway going to a reverse tunnel VPN style deal. That's most common. Instead of making everyone buy their own to fulfill their maintenance contracts, say no remote access, that'll be provided by the system. Better for the contractor, they don't have to think about it. Better for your security posture. And aim for your requirements to be testable and require testing to be part of the system provisioning. So if I go through example specs, testing is everywhere. Functional testing is extremely prevalent. So it makes perfect sense to tie in security testing as just another one of those acceptance test checkpoints where someone can demonstrate, okay, here's what you had in the spec. I'm showing you that I did it the way you wanted it. You confirm, you agree before things go live. Getting back to those examples, right? UFGS, here's Division 25. They're not exactly using the master spec divisions, but it's pretty close. They have this cybersecurity for facility-related control systems. Here's an entire subsection for cybersecurity. So here's somewhere where we can put requirements. Here's a way to make sure that the systems are secure when they arrive on site. If we look here, we've got kind of a sampling of the different divisions. We're calling out documentation that should be provided. We're calling out what should be done during construction. How should the contractor behave? This is where you can add stipulations like, you can't just plug whatever laptop you feel like it into the network. What does that look like if we go through the parts, right? So part one, what are some of the important control points that are being used in this spec to make sure that the cybersecurity posture of the facility is being maintained? Submittals is one of the strongest one, right? So if you put on a project management hat and you think about what the work is, you've got your deliverables, and that is document submittals and the system at your place doing the job it's supposed to do. Those are your broad categories, right? So the documents that you require to be shipped with your system is a great way to make sure that people are doing the thing that you want them to do, not because you're telling them exactly what you need them to do, but they have to tell you what they're going to do, and they have to think about it and tell you what they're going to do, instead of it just being left nebulous, right? And it gives an opportunity to review, make sure things are in compliance. Requirements, right? We're talking about vetted vendors, restricting people who are going to maintain, restricting the bid process to people who are going to maintain your organization's posture. Fits right in with other regulatory requirements. This is an example, not UFGS. This is just another university spec. This is at Division 42. So it's for a powerhouse. So here we can see we're referencing out to an external standard, right? We're raising the question, hey, this system needs to consider security when it's being developed. If we look over here about networks, we're saying that the network has to be designed and reviewed by a competent person before it shows up. What can we do with part 2? We're talking about daisy chains, right? So earlier we looked at a spec that didn't speak about them. Then we saw one where it said no daisy chains allowed, which is, reasonable posture, but it does make challenges in that it reduces the tools that the vendor has to provide a robust, resilient system, right? So if you take away a design tool, it makes things more challenging. So here's a way where we can limit daisy chains, if they have to be used, are only going to be used in those situations where it is relevant. And it can't just be a convenience where you don't want to run 5 home runs, so you're going to daisy chain a couple unmanaged switches. And here's a different part 2 example. Here, instead of just saying network switches are to be provided as part of the system, we've got, here's the device that you have to use. And this is an example of a proscriptive specification. So there's kind of 2 styles. There's performance-based and prescriptive. They both have their place. Performance-based gives more design flexibility, but can make it more challenging to make sure that you're in compliance. Prescriptive, you pick something that you know does what you want. You say that has to be used. You can occasionally allow deviations that have to be approved. So there are different tools for handling this problem. And in this part 2, we've used prescriptive specifications to make sure that the devices that show up are what you want. Moving on to part 3, all right, default passwords. Okay, well, we want them changed. We don't want NESA-SCAN flagging, wheel community public SNMP passwords on PLCs, which they do because they do get shipped with those default shared passwords. You don't want that in the spec. Default passwords need to be changed. List needs to be provided. And testing. Testing also shows up here in execution. That it has to be done and results have to be turned over. So here again is your controls on the way the work is done, the way systems are configured. And going back to that other example spec, talking more about part 3. Here we're getting into details of what kind of application level security do we want on the devices. Instead of just saying devices will have security applied, we lay out the things that are in our permissioning scheme that we want carried across all the systems. So if we have a centrally defined credential store, if we're using Active Directory or a different style of system, we're going to need to have these 3 access levels implemented across all types of different applications. That's something that's appropriate for Part 3. So again, these specs are of the engineering and construction world, and you may be ambitious and want to write a whole specification and hand it over to your facilities group. That's probably unlikely to be the route you want to take. But these are things that you can bring up with them, that you can have them require the engineering firms bidding on the design work to have to include in their specifications, that they have to be capable of adding these things in. So there's lots of different, self-help. You can find examples from the government on best practices. You can ask existing vendors to provide it. Vendors, other groups, consultancies can help you develop the specification sections that are relevant to OT, relevant to implementing the posture and cybersecurity program that you already have for your other stuff into this important slice of your system. And that's the end. Anyone have any questions? Yes?
So this is near and dear to my heart. My new job, this is one of our long-term goals, is to start securing some of these building automation systems that have been in existence for like 30 years. And I work in healthcare. So
Sure.
Where do you even start with something like this? I came to this because I saw building automation and I figured it would hopefully be something like this and this. But how do you, for existing equipment, how do you start, or where do you start in efforts to secure that?
Sure. So the question was, if you are responsible for an organization with existing legacy systems that didn't include security, how do you take the first bite at that? And I would say the right place to start would be facilities, engineering, maintenance, those groups, asking them about them, saying, hey, these things are old or on the network. Are you guys planning to have them replaced, right? Because they're probably thinking about it already too. And they're thinking about it because they can't buy replacement parts anymore. No one really gets how to use that old IBM PC to connect to them. So they want to see them gone too. And you'll start to understand when the opportunities are for replacement. And then when we talk about, what kind of stopgap measures can you take? Well, first you got to define who's going to be responsible for what. So really that people aspect of starting the conversation with the people and saying, hey, we can take care of this for you, explaining why that's good for whoever's responsible for that equipment. Because there's a lot of resistance at first because it's stuff that someone's been responsible for keeping it working and it's been working, and now someone's going to come in and tell them no, you can't do that, or now you got to have 3 passwords to get into the system, and that sounds bad, but it's good for them in the end, right? Because I can also do automated backups for you, and if this computer ever crashes, it'll take 10 minutes. Those are benefits that you can bring. So if you start that relationship and off on the right foot, and then start to find those areas where you can take those bites and understand that you want to move this system to your existing posture, to be in compliant with your program, and it's going to take bits and pieces. Anyone else?
All right, well, thank you very much, Tim, and on behalf of DTI and Secure Delaware, we want to provide this little plaque for you. So again,
All right.
So thank you very much.
Oh.
Thank you all for joining.